Before going into solving the problem, I'm going to discuss with you the basics which are going to help you really in solving this class of problems. I hope you will have the patience to see through the entire video. Let's look at the right hand rule. And if you hold a conductor using your right hand, if the thumb is along the direction of flow of the current, then the direction along which you fold your fingers, curl your fingers, indicates the direction of the magnetic field. That means if you hold it, basically around a wire, the magnetic field is in circles. So which way? Because you need to provide a direction. The circle here is coming out of this side and going into this side. You look at the finger, it is going into the page. Suppose you are viewing through a mobile phone and this is the direction of the current. Here magnetic field is coming out and here it is going in. So how that is represented in general in any textbooks? Suppose this is the wire, a conductor carrying current, and let me draw a two conductor, and if this is the direction of the current, then here magnetic field comes out of it. Suppose if this is the direction of the current, here it is comes out of it. Magnetic field coming out of the screen or the paper or the surface is represented by dots. So the magnetic field is coming out, so we call it out flux. So magnetic flux is coming out of it. And on this side, if you see, the fingers are going in. So here the fingers are going in. So magnetic field is into the screen or into the paper or into the surface. What about, or what if the current comes in the opposite direction? If the current comes in the opposite direction, then you'll have to change the direction of the magnetic field. How you want to change? You will have to change like this. If you hold your right hand like this, if this is the direction of the current, here magnetic field is coming out, here the magnetic field is going in, here the fingers are going in. So let me use this here. So the entire thing is reversed. How it is reversed? Like here the magnetic field is coming out of it, which is represented by dots. Here the magnetic field is going into it. So if you know this instinctively, depending on the direction of the current, how the magnetic field around it, so you can solve most of the problems, even JEE and NEET problems. So you need to understand this particular fact. Then the other type of things, the next thing we need to understand is about a ring. Suppose you have a circular coil. If you have a circular coil, let me say two circular coils, let's have it. Suppose in the circular coil, the current is in the anti-clockwise direction. If the current is in the anti-clockwise direction, then it is again the same right hand rule. If the current is in the anti-clockwise direction, if you curl your fingers along the direction of the current, this here the magnetic field is coming out of it. So it is dots. In other words, if the out flux, so when the current is anti-clockwise, magnetic field is out of the surface or out of the plane. So we can say anti-clockwise current, I'll write it here, anti-clockwise current, anti-clockwise current. When you look at it, that is anti-clockwise. If you go behind it, that seems clockwise. So which way you are looking at it is what more important. So in the anti-clockwise, if when you look at a coil, if the current is anti-clockwise, you will have the magnetic field is coming, you will have the magnetic field coming toward it. So we call it anti-clockwise current gives out flux of the magnetic field. And obviously clockwise current will provide influx, or vice versa. What kind of thing I am talking about? If the out flux changes, either increases or decreases, when the out flux increases, then that gives rise to anti-clockwise. When the influx increases, that gives rise to clockwise EMF. So that way also we can talk about it. If the current is clockwise, magnetic field is into the plane. If the current is anti-clockwise, it is out of the plane. Let's look at the problem right now. Like if this is about a steady conductor, this is about a circular conductor. Now we are going to talk about a charge flying by. Suppose if a positive charge goes in this direction, the direction of motion of the positive charge is the direction of the current. You can assume this as the current's direction. Then when the positive charge goes in this direction, here the magnetic field is actually coming out of it, and here it is going into it. But whenever a negative charge flows into this, whenever a negative charge, let me draw this, whenever a negative charge goes in this direction, then the exact opposite things will happen. What is that? From this side, because when the negative charge goes this way, the current is in the opposite direction. So here the influx and here the outflux. Okay, now we are going to answer the question. Like they have given this particular part, there is a coil, and I'll have all these things up here, and there is a coil here, and an electron is flying by. An electron is flying by. So when the electron flies by, what happens here? Which way the magnetic field will be produced? So first thing, when the electron is coming in this direction, you know that this is an electron, negative charge. So I'll write it here. This is an electron. When the negative charge goes in this direction, here it is influx, here it is outflux. When the positive charge like protons go in this direction, here it is outflux, here it is influx. So here an electron is flying by, it is negative charge. Then obviously this way the flux will come out, go in, and this way it will come out. So when this electron near this coil, so here the electron is far away from the coil, as the electron go in this direction, this influx increases. So when the influx increases, the induced EMF will be opposing the very cause of it. When the influx increases, what happens is that the EMF induced in this will try to produce outflux, so that will affect or decrease the cause, which is the influx. Because when the electron comes this way, the influx of the magnetic field increases. Because of the influx, an EMF is induced in the coil. That EMF, according to Lenz's law, will oppose the cause. What is the cause? The influx is the cause. It will try to oppose the influx. In order to oppose the influx, it has to produce outflux. Outflux meaning it has to produce anti-clockwise current to give outflux magnetic field. So when the electron approach up till this point, when the electron approaches the coil, influx increases and produce EMF. But the EMF should oppose the cause. So the EMF has to produce outflux. In order to produce outflux, it has to produce EMF in the anti-clockwise direction. Hence, anti-clockwise EMF is induced. But when the electron leaves from here to here, during this half, when the electron go away from the coil, this influx decreases. So when the electron moves away, influx decreases. When the influx decreases, that produces EMF. So it has to oppose the reduction of EMF now, a reduction of influx. In order to oppose the reduction of influx, it has to produce more influx. Hence, the current has to be clockwise. So it will produce EMF in the clockwise direction. I hope you understand the part. If it were a positively charged, when the positive charge approaches the coil, first clockwise current will be induced. When the positive charge leaves the coil, anti-clockwise is produced. So when a negative charge, so let us summarize this. Suppose you have a coil. In this coil, when a positive charge, suppose Let us assume that it is a positive charge. When the positive charge flies by from here to here, if it is a positive charge, first up till this point, it is here clockwise in this, and then anti-clockwise during this part. Then if the positive comes from this side to this side, then clockwise and then anti-clockwise. If it were a negatively charged, just as we explained now, when the negatively charged particle flies near a circular coil, see, first is anti-clockwise and then is clockwise. Up till this point, it is when the negative charge flows from here to here as it is nearing the coil, first anti-clockwise and then clockwise. Remember this part. This will be very crucial when you answer questions.